Hi, everybody. Welcome back. This is where we stopped last time, the structure formula. And the structure formula is a formula that shows us the atoms, the type of atoms included in the compound, the number of atoms, and the bonds, how they bind together, how they bound together. So the structure formula gave us the same information that we get from the molecular formula. And if anybody needs to know more about the molecular formula, you can go back to the previous videos. Same playlist. Okay, so the structure formula gave us the same information that we get from the molecular formula plus how they bound together, the bonds, the bonding in that molecule. Like here in that compound, bromine is linked to 3 fluorine atoms with 3 single bonds. Nitrogen is linked to 3 hydrogen with 3 single bonds. Carbon, here we have a double bond, and all the other bonds are single. We have 3 carbons and 6 hydrogen. So as you know, as you can see, we know from each structure, from structure formula, what are the elements that involved in that compound and how many atoms of each element and what are the type of bonding. Empirical formula. Empirical formula is the simplest form of the compound. The formula that cannot be simplified more of this compound. A formula for a compound that shows the simplest ratio of atoms. The simplest ratio of atoms. Okay? Like, for example, the simplest, the molecular formula of ethane is C2H6. Okay? So what is the ratio of the atoms? The carbon, 2 carbon to 6 hydrogen. So we can simplify this ratio. Yes, we can divide by 2. So H1 carbon needs 3 hydrogens. So 1 carbon to 3 hydrogen is the simplest formula. So empirical formula of hydrogen peroxide. The ratio of hydrogen to oxygen. So we have 2 hydrogens to 2 oxygens. So we can simplify it more. Yes, we still can simplify this ratio by dividing divide by 2. So we will have the ratio is 1 to 1, which is 1H and 1O. This is the empirical formula that shows us that every 1 hydrogen needs 1 oxygen in hydrogen peroxide. Fine. C2H2, we can simplify it more to the empirical formula by dividing by 2, and the ratio, the empirical formula will be CH. This methane cannot be simplified, so this is the empirical formula, CH42, because this is the simplest ratio of that compound. So that's to remind you that chemical formula can be empirical, molecular, or structure. The empirical is the simplest form of the molecular formula that shows us the simplest ratio of each element in that compound. Molecular formula shows us the actual number and type of atoms that is involved. without showing the bonds, how they bind together. The structure formula shows us the actual number of atoms, the types of the atoms, and the bonds between them. This is an example, hydrogen peroxide, showing us the chemical formula, its empirical, and its structural formula. So the chemical formula is H2O2. Show us the exact chemical formula. So how many in the end? How many in that? How many atoms of each type exist in that compound? The empirical formula is the ratio, the simplest ratio of atoms in that compound. So here we can divide by 2 to see the simplest ratio. So we don't write a hydrogen peroxide like that, but this is the ratio of each atom in that compound. And this is the structure. As you can see, the bonding between the elements. Okay. So we have other examples. So molecular formula and its empirical formula. To get empirical formula from the molecular formula, we can simply see whether there is a common factor or not. Here C2H6 is the common factor is 2. If we divide by 2, it will be C, and this will be 3, CH3. C4H8. So we have a common factor 4, so we'll divide by 4, and 8 when divided by 4 will be 2, so the empirical formula is 2. The glucose C6H12O6, so the common factor between all of them is 6, so when divided by 6, it will be 1, 2, 1. So the ratio is CH2O. Okay, so this is the structure formula of ethane. The first one, C2H6. So C2H6. C is bound to 3 H's, as you can see. Propan, C3H8. Okay. Propan C3H8, so this is the same as empirical formula because we don't have a common factor. We couldn't divide 8 by 3, so it will be C3H8 the empirical formula. Here too, this is a structure formula. Of the ethanoic acid. Sorry, of the ethanol. Okay. So we can see how many carbons, how many hydrogen and the oxygens. Butane, C4H10. So to get the empirical formula, we get the factor first. The common factor is 2. So when divide 4 by 2 will be 2. And 10 by 2 will be 5. And this is the empirical formula. The octane, C8H18. So the common factor is 2. 8 by 2 is 4, and 18 by 2 is 9. So this is the empirical formula of octane. So simply, when you try to get the empirical formula of any compound, try to get the common factor to divide the number of atoms, the number of each atom that can accept the division of the number of each atom to get the simplest ratio of the atoms. These are some examples of some compounds Sodium chloride, NaCl, the ions, sodium, ion plus 1, and Cl, the ratio is 1 to 1. 1 sodium to 1 chloride. Ammonium nitrate, ammonium is a compound ion. Remember, there is a compound ion, which is the ammonium. Another compound ion, nitrate. Ammonia is NH4 positive 1, and the negative ion is nitrate, and the ratio is 1 to 1. 1 ammonia to 1 nitrate. Potassium sulfate, potassium and sulfate. Sulfate is a compound or molecular ion, and the ratio is 2 potassium to 1 sulfate. Calcium bicarbonate or hydrogen carbonate. By the way, this is bicarbonate or hydrogen carbonate. Okay, so 1 calcium to 2 hydrogen carbonate, and these are the ions. Copper sulfate, 1 copper to 1 sulfate. This is the ratio. Magnesium nitrate, 1 magnesium to 2 nitrates, 1 to 2. Aluminum chloride, 1 aluminum to 3 chlorides, 1 to 3. So your homework. So you have this homework before in another video. So you already tried to practice it before you know the molecular formula and the structure formula, and how you can add ions together. So you already get to think about it before, but I think now it will be easy if you try it now. Try the same homework now. Now you know how to name the compound and how you write the formula of the compound, and how to balance the ions, to write the valency of each ions. Okay, so things will be easy now for you, and don't neglect it. Try to solve it. Write down in the comments down below. And practice as much as you can. Practice for this chapter. Practice as much as you can. Okay, these are 2 examples. Take a screenshot so you can solve them. And that's all for today. Thank you guys for watching. See you. If you have any question, don't hesitate to write down in the comments down below and I will reply you. Thank you and see you. Bye bye.